Hello and welcome to Season 2, Episode 8 of LogiCast, the AWS News podcast brought to you by Logicata. I'm Carl Robinson, CEO and co-founder of Logicata, and I'm joined, as always, by my colleague, John Goodall. How are you doing today, John?
Oh, I'm on cloud bloody nine, mate. I'm envious of your jumper. I am. I want one of them.
This is the AWS Community Builder hoodie of protection. Which I won when I was previously an AWS community builder for my content contributions to the AWS community. And I thought I'd wear it again today. If you're watching, you'll be able to see. If you're listening, you'll just have to imagine it. But I thought I'd wear the AWS Community Builder hoodie of protection again today because over the weekend I received the delightful news that I was once again selected into the AWS Community Builder program, followed shortly by another email to say that I was not accepted into the Community Builder program, followed again by a third email to say, if you received an email to say you're in and want to say you're out, you're definitely in. So I think I'm definitely in the program again.
But I wonder if they put you in because you're in, or they sent you one saying that you're in by mistake, sent you one saying you're out, and then felt bad.
I don't know, but the funny thing was I read the out one first, so I spent most of the day being disappointed that I hadn't got back in to the community. And it was only later in the day when I received the third email that I then noticed the first email that I'd overlooked earlier in the day. So so I think I'm back in the Community Builder program, which is great. It is a thriving global community of budding AWS enthusiasts who are regularly creating content and contributing content. And in addition to the great news about me being accepted back in again, you've also been accepted into the community, John.
Yeah, I know. It's great. I mean, I had the same email pong, but I read them in the right order. So I got the one saying you're in, and then I got the one saying, sorry, you're not in. And I'm sitting there going, huh? But like, okay, fine. I'll sit there and wait for kind of all the next steps and things that they listed in the first email. And then I got the third email kind of the next day saying, sorry, but you are in. Cool. Excellent. Yep. Wonderful.
So I think we're safe to say that we're in.
Probably.
Hopefully there won't be any more emails to the contrary. But anyway, you admire my hoodie. I'm not sure you'll definitely get one of those because they are quite exclusive to hoodies, but you will definitely get an AWS Community Builders cap, which obviously does not fit over my headphones. I should have put it on first. Yeah, along with some other delightful AWS Community Builder swag. That is not the only reason to join the program, of course. There are other great benefits to joining the program. But I'd like to think that our little LogiCast podcast was a part of why we're on the program. And moving forwards, we have a plan to invite other AWS community builders onto the LogiCast podcast as our guests. So watch this space or listen to this space if you are also an AWS community builder, because we'd love to have you on talking about AWS news. So that, of course, is the purpose of the LogiCast podcast. Every week I collate a newsletter of news that I've personally curated from around the internet. And John and I pick a subset of those articles that we would like to talk about in more detail. So we've got a list of articles this week that we have selected. The first of those is on InfoQ, and it is about Amazon releasing Elastic Kubernetes service for Snowball Edge. So I've always been a big fan of the Snowball devices. I think I need to find a reason to have one delivered to my shed, just for, fun. I was going to say something rude then, and I realized
I know what you were going to say
afterwards. But yeah, so just for fun, I'd like to have a Snowball Edge delivered to my shed. The Snowball Edge, of course, the ruggedized storage and compute devices that Amazon provide that run various Amazon services on them, and now you can run your EKS clusters on Snowball Edge. So what does this mean, John, for the user base?
It's a funny one, right? Because Snowball originally was just a storage transfer device, right? They'd send you this ruggedized case with a Kindle for the shipping label, which I've never gotten over. It's always thought that was really cool. And you hook it into your data center through like a serial connection or a gigabit Ethernet or whatever it was, and you shove a load of data over onto it, and then you post it back to Amazon because even in today's day and age, it's actually faster once you get above a couple of terabytes to send stuff in the post than it is to send it over the internet, even in today's day and age, right? Because local transfer is just that much faster. Then they did a few iterations of that, the Snowmobile with the big truck and all the rest of it. And then they did Snowball Edge, and that just adds compute to it. The original logic of that, I guess, was so that you could do work on the data sets on the device whilst it's in transit, I suppose. But then this sort of starts to blur the lines between Snowball Edge and Outposts, because AWS Outpost being the kind of the rack mountable server that you put in your own data center that lets you run AWS services in your own data center. This kind of blurs that line. It feels like an Outpost mini, but they just didn't want to call it that, if you like. What this means is you can run Kubernetes on these because you're insane. Why? If you really have a need to run Kubernetes workloads, I would implore you to talk to a therapist. But if you have active Kubernetes workloads and you want to run them in your own data center, but use EKS because you don't want to manage the control plane yourself, that's what this is doing. Because in my experience, having run Kubernetes workloads, no, I haven't had therapy. I just went serverless instead. The control plane is the most complicated area of it. Running the containers and getting those kind of all configured and doing your taints and tolerations and making sure you can set things in certain servers and all that kind of thing is fine. It's really not that complicated. Bit of a mental jump if you're just used to servers, but it's not too bad. The control plane, however, is hideously complicated because you've got to worry about pod schedulers and instance schedulers and networking and all sorts of other nonsense that you just don't really want to have to. I mean, this is why CKA and CKAD, the Certified Kubernetes Administrator and the Developer Cert, are so hard, because the CKA one in particular focuses a lot on control plane, which is the complicated bit. So what this does, I suppose, is means you can run Kubernetes workloads on premises, not on premise, on premises, but use EKS to kind of orchestrate them on a device that can do other AWS things, rather than just, installing EKS anywhere on a server that's stuck.
So I'm just fiddling around with my lighting in the background. You might have noticed. I was actually trying to turn the heater off, but remembered that the lights are connected to the same socket. So,
oops.
So let's go without the lovely coloured lighting in the background for the remainder of the recording. But yeah, I guess there are some use cases for wanting to run this stuff out in the field. Outpost is all very well if you've actually got a data center, because it's a rack, or these days it can be a server or some servers, but you've got to have somewhere to put them. But if you are genuinely out in the field or a field, then this could come in handy. So I guess perhaps construction sites, for example, before they've really established any serious
What are they doing running Kubernetes?
I don't know. But oil exploration sites, perhaps lots of data to analyze.
I could see a list for that. I could also see a use case for things like offshore cargo ships and stuff, because they go through areas of absolutely abysmal signal, and you read these really cool things about how they end up even having to chunk emails and do things in batch when they actually come into range and that kind of thing. So I could see a use case for that, I suppose.
And of course, space. They did send a Snowball into space, I believe. Not an actual Snowball, a Snowball Edge device. Although Snowball probably survived quite well in space, because it is cold up there, isn't it?
It's like 7 degrees above absolute zero, so survive is an interesting choice of term.
So yeah, so if you want to run Kubernetes in space, you can. It's now possible. I was thinking of pigs in space from the Muppets then, but Kubernetes in space. So let's move on from Kubernetes in space to our next article. And I picked this one especially for you, John, because
you picked it. I didn't realize you picked it.
Yes. I pick the articles that go into the newsletter.
Yeah, okay. Yeah.
You then pick them from the newsletter. You don't get to pick anything that I haven't already picked.
That's really
That's
disturbing.
how it works.
That's a really disturbing thought.
Yeah, let's not go down that rabbit hole. But anyway, let's stick with the subject matter. So this article that I initially picked and then John picked from my pick list is about detecting solar panel damage with Amazon Rekognition custom labels. And I knew John would like this because he's got some solar panels. I would imagine he's hoping that they're not already damaged because he hasn't had them for very long. I must admit, I was a little bit disappointed when I read this article because it's quite an exciting headline, I thought. And then as I read through the article, I was hoping that they were going to be doing this from satellite imagery. So, from Kubernetes in space, you might be able to detect your solar panel damage. But it wasn't quite as exciting as that, but still pretty interesting nonetheless. Using images of your solar panels that you need to take yourself, you can use Rekognition to detect damage. So why did you pick this one, John?
Well, I don't think this is particularly useful for me as like a home installation, right? Because if I want to check whether my panels have got damage, I look at my roof. Yeah, I can see it from my shed. I just look. This is much more useful for solar farms, right? And you see them quite a lot in areas where farming has become economically unviable, where farmers have just turned field after field after field over to solar panels because they make more money from it. But the downside, of course, of that is the maintenance can become a real problem because you've got hundreds and hundreds and possibly thousands of these panels, and you start getting damage on them, and they don't stop working, but they stop being as effective. And because I'm an enormous nerd, I understand the engineering behind solar panels because I looked into it when I had them installed. I'm not going to go into enormous detail, but the short version is if you get damage in one area of the panel, it's not just that area of the panel that's affected. It drops the efficiency of the entire panel or of half the panel or of a section of the panel, depending on the tech that's been used, right? So it's very important to actually know where these problems are so you can pick the panel out, put a new one in to keep your efficiency nice and high, because the maximum theoretical efficiency of a solar panel is something like 33%, right? Of all the light that hits it, it's something like 33% can be transformed into electricity. That's the maximum theoretical efficiency, and we're not there yet. We're at more like 20-25%. Because of things like visible spectrums of light, and I'm not going to go into the physics, but the point is,
this is about AWS, not physics.
Not physics.
So, that's a different. We can start a different podcast about physics of solar panels if you like, but
But the short version, it's important to know where and when there's damage, and so you can solve it, so you can keep the efficiency of your array up. But of course, walking across acres and acres and acres of fields to check these things is not really viable because you'd be doing it. It's like painting the Severn Bridge. You'd be doing it forever, which is not amazing. It's not what you want to be doing. So with this, and I think it is done in small scale, a rover wanders around your field, takes pictures, uploads it to S3. It has to be done through S3 because that's where Rekognition reads files from. Uploads it from S3, and then Rekognition using custom labels. And custom labels are just a way of training the model, if you like, to say, I care about these, I care about those, that kind of thing. You throw it into Rekognition, which is their AI as a service, and it tells you that there's damage or that there isn't and where it is and highlights it and all the rest of it. So that's really cool because what it will end up doing through this particular solution that was done at the 2021 Builders Fair, so it's quite cool, quite recent too, is you can see this panel in this section has damage in these areas, and then you can decide what to do with that data. But yeah, like I say, for home use, not massively important, and never mind the fact that I have a 10-year warranty and something on the damage and a 20-year efficiency warranty or something like that. So it's not something I really need to use, but for enormous solar farms, very, very useful.
Well, you might have a warranty, but you still got to know that they're damaged in order to get them repaired under warranty, I suppose. So,
but my point
which
is
the same will apply.
To...
depends how bad the damage is, I suppose.
This is true.
Perhaps you might need to get a drone to get up there and get some nice
Oh, don't
4K
tell
images
me
of your solar
that,
panels.
because I'll just have to buy one. I want
I,
one, but
I'm amazed you don't have one already.
they're like 500 quid for a reasonable one. I can't warrant that.
I did buy one a few years ago for my son, and he was delighted. I was also delighted because I got to have a go. But the novelty wore off fairly quickly. Although I would really like a drone that would follow me on motorbike tours to get some fantastic scenery footage of us riding through whatever mountains we're riding through.
I see people using 3D 360-degree cameras for that sort of thing, which is quite cool, because they've got some quite clever software that takes out like the stick and things that they're sitting on, so it looks like a drone's following you when the camera is just kind of about there. Yeah.
Anyway, that's again another subject matter. So let's stick to the AWS news subject matter. Let's move on from detecting solar panel damage into porting advisor for Graviton. So I don't think we'll digress quite so much on this one. I don't think there's as many opportunities for us to go off on tangents here. But obviously, AWS really pushing their own silicon now, Graviton, which is up to the 3rd generation Graviton 3 processors. We're seeing a lot of interest from our customer base in porting their applications over to Graviton-based instances, whether that be EC2 or RDS or other compute services which are backed by Graviton, to take advantage of the better price-performance ratio offered by AWS's own silicon. And I can't quote any of the ratios off the top of my head, but it is better and it is cheaper. But not all workloads can run on Graviton. So AWS, as they often do, have helped out with a tool called Porting Advisor for Graviton, which can help to advise you whether or not your workloads are suitable for Graviton. So what can you tell us about this one, John?
You said Graviton a lot in that intro.
Well, the article's about Graviton, so yeah. Maybe you could use Rekognition to do a Graviton counter and just to add a little ping every time I say the word Graviton.
Oh, I'll turn it into a drinking game. Okay, so this is quite cool tech. If ever you've worked with code scanners and code quality tools and all that sort of thing, you'll be used to this conceptually, right? Because there's not, annoyingly, a way of just uploading your binaries and go, scan this. It tends to be done at like build time, so it needs to run locally. What this is doing, as you say, is this is working out whether or not your existing workloads can run on, it's Graviton specifically, but probably ARM more generally. And these days, if you're working on a modern Apple Silicon Mac, you're working on ARM. So odds are it'll work, right? But this is just confirming that, because I've absolutely developed things that then have upstream dependencies that don't play nice with ARM, because it happens occasionally. It's a lot less common than it used to be, but, you know, it's still a thing. What this is doing, as I say, is this is checking build time for things like assembly with no ARM equivalent. It's looking at ARM architecture. It's looking at libraries that aren't available for the ARM architecture or anything sort of architecture specific that you're trying to do. That's more suitable for embedded systems. But, you know, it's a thing. And then usages of old runtimes for Visual C++. That's for Windows specifically, right? Using the tool is not particularly hard. Like if you're building these applications, you probably won't struggle, because you need to know how to build it and you need to be able to script in sort of Python or Bash or PowerShell. Right? And then if you're building C and C++ applications, you need to know hardware or compiler specific instructions, which again, if you're building those applications, you probably know them anyway. So I wouldn't really worry too much. But yeah, what this is doing is runs as a Python script or an exe on Windows, builds the binary, checks, you build the binary, and then you run it against your scripts and your code and all the rest of it. It then slings up a report into the AWS console, much like most of these tools do. They run locally and then they connect off to a console. And then it kind of tells you how many files have been scanned, how many issues have been found, what the issues are, so on and so on and so on. You can then export the report so you can share it with people that don't necessarily have access to the AWS console, and then you can go off and kind of work out how to solve those problems. What's important to note is, and they say this a lot in the article, is it doesn't change your code. It will not make it magically work on ARM for you, okay? It will just tell you where the problems it has been configured to look for exist. You know, you've used this, there's not an ARM binary, that kind of thing. It's relatively quick. Because again, in the FAQs, how fast is the tool? It scanned 4,048 files in 1.18 seconds. So it's, you know, relatively quick. So that's important to note. The other thing that's important to note is the language support. And I know we touched on this in sort of our preamble. It's very much geared towards what seems to be embedded type systems. C++ is talked about quite a lot. Golang is talked about quite a lot. Java, you know, so this is not web facing, if you like, which is annoying because I'd really love to run PHP apps on ARM, but there we are.
Yeah, it doesn't mean you can't run PHP apps on ARM. It just means you can't use this to tell you whether or not you can run PHP apps on ARM. So we did identify that limitation because we thought it might be useful for a couple of our clients who were considering the move to Graviton. So we identified that limitation fairly quickly. But perhaps, as is often the case with these things, it will develop and you know, some of those other web type app platforms will come into scope.
I don't know. I think they might, but in my experience, those web type platforms have a lot fewer issues with, you know, OS specific binaries because they just get compiled at runtime and they just run. The only issues I found with Python particularly have been image manipulation libraries, but everything else, not really had a problem.
Cool. So let's move on from that to our next article, which is about maintaining code quality with Amazon CodeCatalyst reports. So this one, very much your forte, John. I don't have a lot to say because I'm not really a developer. I'm not really a developer. I'm not a developer at all. I don't think I've written a single line of code.
We're going to have to change that.
But,
let's see if I can't get you to write some PowerShell or something. That's barely code.
Yeah. Well, it would be quite nice because then I could write a blog about it and it would help me with my AWS community build a renewal application. So, yeah.
Only just got in. Got to think about how to get the renewal.
So, yeah. So I think I actually discussed this one with you last week anyway, in relation to a project you were working on. I asked you if it's something that you could use because I think you can use it to create unit tests and or run unit tests and so on and so forth. So tell us about how you can maintain your code quality with Amazon CodeCatalyst reports.
So this, from what I can tell, and I've not worked with it before, but I've worked with what I believe to be similar tools. What it's doing is it's running your unit tests for you. It's taking the reports of those unit tests, and then it's giving you, it's also doing code scanning and white box testing where it's analyzing the code. And it's giving you, you know, here are the problems that I found. Here's your code coverage. Here's your pass fail rates on your tests and all that kind of thing. Excuse me. This isn't particularly new ground that AWS are cutting here because I've worked with at least 2 other tools that do a similar thing. I forget the name of one of them, but the other is SonarQube, Sonar Cloud. There's another one out there as well that I forget the name of. But the idea being that, you know, again, same with Porting Advisor, you run this at build time, at compile time, at package time, whatever, or in languages that aren't built, compiled, packaged, you just run them against your native code, like Python. And it scans them and reads your unit test reports and all the rest of it. And it gives you this really nice kind of dashboard that says, in your security area, you've got these problems. In your operations area, you've got those problems. Your unit test coverage is, you know, 80%, which is pretty good coverage. Your pass fail rate is this, and so on and so on. And that's, again, what this is doing. You look at the report run overview, and it's run a number of test cases in test suites, and it's got, you know, pass fails, and it's got pass rates and all that kind of thing. And then, again, further down, you've got unit coverage, line coverage, branch coverage, yada, 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 yada. It goes on and on and on a little bit. But the idea being that this is a way of tracking the quality of your code across your project. Yeah, because particularly in large projects, we've got our unit tests. We've written unit tests. Have you really? I mean, yes, you might have written them. When was the last time you ran them? What's your ratios? What's your coverage? You might have some unit tests, but you might have 5% coverage and they're all failing. So what's the point? This is the sort of tool that kind of helps with that. And again, like I say, this isn't the only tool in the market that does this. There's at least 2 others that I'm aware of, and that's just off the top of my head. I know. I'm sure if I did some Googling, I'd find some more. Scrutinizer, that's the other one. Just remembered it. Apologies to the listeners. I rather shouted that. But
it didn't come through
others.
too loud. I didn't have to relieve the headphones.
But the point is, because this is in AWS, if you have those criteria that we come up to every so often about your code must stay in AWS, your applications in AWS, everything must stay in there, rather than having to vet lots of vendors or flit it across the internet or whatever, this solves for that, right? Like I say, it's not a new tool particularly. It's not a new idea by any measure, but it solves for the code co-location problem.
Cool. Well, we all have a bit of scrutiny, so anything that can help to scrutinize. But this is not scrutinize. Obviously, this is CodeCatalyst. Yeah, nice. Thank you. So let's move on to our final article for this week, which is about developing portable AWS Lambda functions. So, John, you love Lambda, you love serverless. You love serverless so much you're now an AWS serverless community builder. I thought this one was quite interesting because one of the major criticisms often levied towards serverless is vendor lock-in. So if you go too far down the AWS Lambda route, then your apps that you've developed will only run in AWS Lambda. So if you want to port to another cloud, you might be a bit stuck without refactoring your application. So this article gives some tips on how you can develop portable Lambda functions, which could potentially be run in containers as well as Lambda. And of course, once they're in containers, that means you could run them anywhere on any other public cloud or on your on-premises cloud. So we know why you might want to do that. Yeah, tell us more about the how, John.
So I think it's worth touching on my biases in this area, because everyone has biases. Mine in this area are, I do not fundamentally buy vendor lock-in. Okay, I don't buy it because yes, okay, you won't be able to move your natively developed code to GCP, but it's hard enough getting stuff running in multiple regions. Why would you want to leave your cloud provider? So I fundamentally don't buy lock-in, but I will accept that other people do. So that's a thing, right? With that out of the way, how you're doing it is by rather avoiding using anything that would kind of lock you in. And it's also taking any and all of the logic out of the handler. So the handler, for those that don't know, is the function that the Lambda service invokes when calling your Lambda. Okay. Most people call it Lambda handler or something of that nature. You could call it in. It doesn't really matter. You tell the service, when you invoke this function, call that function name, call that class, whatever, right? So take all of your logic out of there, because that way you might still have to do a bit of refactoring, but it's going to be a lot smaller. It's also worth knowing, of course, that the handler in Lambda terminology is non-cacheable. So between invocations of Lambda functions, anything that's in the handler will not be cached. Anything that's outside of the handler can be cached, okay? So there's reasons as well in just staying in Lambda for why you wouldn't want that to happen. I wouldn't want my database connections to potentially to be cached, but I would want other things to be cached, okay? So there's that. So this is a little bit at odds with that, but there we are. And then the other area is you've got to worry about the event source and the downstream targets, because again, the Lambda service kind of does this a lot for you. You don't have to worry about it per se. You don't have to potentially, iterate messages or worry about scaling or all of that jazz. You have to do that with this. Okay. So you have to write all of that yourself. And then again, with things like polling SQS, that was the example that they're using, you would have to write an infinite loop to poll messages from the queue, as opposed to not do that and just have the Lambda service poll the queue for you. Yeah. So yes, okay, this is a thing. You could do it. I wouldn't recommend you do it, because what you're doing is adding probably 30% to your workload because you're having to do a whole lot that the service is doing for you. And B, you're then missing kind of the point, in my opinion, of being able to use this serverless compute, because you're having to worry a lot more about things that it's just taken away from you.
But if you're a developer who's charging by the hour and your client is massively concerned about vendor lock-in, then you're probably quite pleased to hear that it's adding 30% to your workload, because could potentially add 30% to your income as well.
Oh, you salesman, you.
Yeah. Well,
it's a funny one. No, it is a funny one. It's a viable concern for some people. It's just not one that I share, and I don't think I will ever share it.
That's fair enough. Yeah, I guess it depends on where you're working at the time, the project you're working on, and so on and so forth. Not particularly relevant to anything we're doing right now, but must be relevant because
I mean, I've had this argument with people in big finance shops and stuff back when I worked in finance, and it's, we don't want to be, we're going to use Terraform rather than CloudFormation because we're worried about lock-in. What? You're just saying words and not understanding what they mean, aren't you? That's what's happening here.
Often the way. It's certainly in my world, anyway. But so anyway, that brings us neatly to the end of this week's episode of LogiCast. That was episode 8 of season 2 of LogiCast. So thank you very much for listening. We'll be back next week with another episode for you. See you again next time.